Okay, so let's get back into chapter 18. Okay, we got into it last time on aldehydes and ketones. Okay, we spent a lot of time naming those molecules. Okay, now we're going to get into some more reactions. That's basically the rest of this chapter is just filled with reactions. Okay, so let's look at one other way. One other way to make a ketone, and we saw a couple other ways last time. And another way is from nitriles. Okay? So remember what a nitrile is. Okay? That's where we have a C triple bond N on the molecule. It's a nitrile. Oftentimes the nitrile group will be condensed to CN, so a lot of times it won't show the triple bond. But there's a reaction we can do on nitriles. Let's look at a particular nitrile. This one here. Okay. And what we're going to do is react this nitrile with a Grignard reagent. Okay. So remember, a Grignard is when we have MgBr on a carbon-based molecule. Okay? And this is a two-step reaction. So we first of all react with the Grignard, and then secondly react with H3O+. Okay? And I'm not going to hold you accountable for any mechanism. I just want you to be able to know how to draw the product, okay? So let me show you how to draw the product, okay? So what's going to happen is the Grignard adds to that carbon there, and the C triple bond N converts to a carbonyl. Okay? So make sure you write that down so you don't forget. Okay? Now you're studying spectroscopy, but write these little hints down so you remember in the future. So if we do that, okay, so the C triple bond N converts to the carbonyl, and that Grignard has then added to that carbon. Okay? And so we get a ketone, don't we? Okay? Where both sides of the carbonyl are carbon atoms. Okay? Let's take a look at another example. Suppose I gave you this two-step reaction. Okay? You see how the functional groups should tip you off as to how to remember? You see that? If I see a nitrile group in there, CN, okay, that should be tipping me off, and I see the Grignard reagent, that should really tip me off, and I'm going to form a ketone. Okay, so what's going to happen? That CH3 will add to this carbon, and the CN transforms to a carbonyl. Okay, so we get something like this here. Okay, where the methyl group is added to that carbon, and the CN is transformed into the carbonyl. Okay. Any questions on that? Okay. There were no cell phones in class. Okay, so you should be keeping track of these. I see one person putting them on note cards. You're putting them on there, they're done, you don't have to worry about them, do you? Again, key thing, keep putting them on note cards so that you remember them for your index file, okay? Okay, so those are the different ways to make aldehydes and ketones. So now we're going to shift in this chapter. The rest of this chapter will be focused on one primary topic, and that topic will be the reactions of aldehydes and ketones. Okay? So this will be the rest of the chapter. Okay? So all the chapter is made up of is naming aldehydes and ketones, how to make aldehydes and ketones. Does anybody remember the primary way we made aldehydes and ketones? From alcohols. And what was the key? Yes, PCC. Good. Okay. Now, we're just going to do reactions on these. And they're going to be different reactions. And we're going to start with probably the most bizarre reaction and get it out of the way. It's kind of a reaction all to itself. Okay? And this reaction is what's called the Wittig reaction. Okay? Not the Wittig, the Wittig. Okay? It's German for W. Okay? So let's look at the Wittig reaction. Okay, this is found on page 843 of Wade. Okay, so you can review this monster of a reaction. Okay. And here's the setup of this reaction. Okay. We have our carbonyl compound here, which is an aldehyde or a ketone. Okay, so that's nothing too bizarre. But here's the bizarre part, what we're going to react it with. We're going to react it with this thing here. Okay, something new. Okay, this is what's called a phosphorus ylide. Phosphorus ylide. We'll talk about that more in a little bit. Okay. But here's what goes on in this bizarre reaction. make sure you write down the tips I give you. This carbon here is going to bond to this carbon here of the carbonyl. Okay. And it's going to bond by making a double bond to it. Okay. And the phosphorus group here just leaves. So we don't have to worry about that. Okay. But you see what the Wittig reaction does? We get the formation of an alkene. An alkene. Okay? So very bizarre reaction. This guy named Wittig discovered it, and so he gets his name associated with it. Okay? So whatever this carbon is, next to the phosphorus, it double bonds to that carbon, and the oxygen is substituted for it. Okay. So let's look at an example reaction. Let's go ahead and make a real aldehyde or ketone. Say that one there. And let's make a real phosphorus ylide. Okay, so we're just replacing those R groups by carbon groups. Okay. So what's going to happen in the product? This carbon will double bond to that carbon. So let's show that. Okay. And this carbon comes along with the hydrogen and CH3. Okay, so those things just come along for the ride. Yeah.
And we just wrote a straight across instead of doing it that way, was that okay?
That's fine. Okay. All right, well, we'll look at some more examples of this, but what I want to do is focus in on this phosphorus ylide, something new to us, and look at how this thing here forms. Okay, so let's call this section how to make the ylide. Okay. Well, there's two steps, two reactions involved to make the ylide. Okay. Let's look at step number one. Okay. Step number one, we take our phosphorus compound. Do you remember what pH stands for? The phenyl group, okay, or benzene rings, okay? So just by way of reminder, this is representing 3 of these here on the phosphorus, okay? Just makes it easier to say pH 3 so you don't have this clumsy structure, okay? So let's stick with this thing. So we have a lone pair on the phosphorus. And what we do is we take this compound that is called triphenyl phosphine. Okay? And what we're going to do is react this with an alkyl halide. Okay? In this case here, it's an alkyl chloride. Okay? And here you can, if you know your chemistry, you can predict how this will go, shouldn't you? You've got the lone pair on phosphorus. Let's just do a simple substitution reaction. Attacks there, kicks off that chlorine. Okay, so we learned that in 241. Okay, so here the phosphorus now has 4 bonds. So that gives it a positive charge. We've lost an electron. And chlorine is Cl minus. Okay? And this thing here is what's called a phosphonium salt. Phosphonium salt. Okay. So this is the first step in making the ylide. Okay. Let's look at the second step. In the second step, we take our phosphonium salt that we formed, highlighting the hydrogen here. You'll see why in a second. And what we do is we react this with butyl lithium. Okay, so just a butyl group attached to lithium. And let's see what happens in this reaction. Okay? This compound is going to act similar to a Grignard reagent, where what we can basically do is remove this lithium and put a lone pair on that carbon atom. Okay? So this thing here is going to be very basic, a very strong base. And what do bases like to attack? Protons, hydrogens, or something, an acidic hydrogen. So this hydrogen here turns out to be very acidic. Okay? We got phosphorus with a positive charge. It doesn't like that, so it's pulling electrons. So it's going to be pulling those electrons toward it to make that acidic. So this butyl lithium says, well, I'll take advantage of that and take that acidic hydrogen to give you the product here, which is the ylide. So you want to know these two reactions in the Wittig reaction. Okay? This is how to make the ylide, which can then go on and react with what? A ketone or aldehyde, or simply the carbonyl of the ketone or aldehyde. Okay. Any questions on that setup there? So you should be familiar now, once you make an ylide, to go ahead and react it with the carbonyl. Okay. So this carbon will attach here to form a double bond. To give you that product there. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Any questions on that? Okay. So that's our bizarre reaction to get out of the way. Question? So took this and reacted it with something like that. And then this thing is on here. Give you something like that. Okay. Okay, let's look at the next series of reactions that we'll take a little bite into today. Okay? And these are what are called nucleophilic reactions. On a carbonyl. Okay? And our possible nucleophiles that we're going to look at include a Grignard, water, or an alcohol. Okay. So we want to study each of these three acting as a nucleophile. Okay? So we're going to look at today the Grignard. We'll save these two for Friday, which are a little bit more involved. Make sure you come on Friday. Okay? So you'll get blasted. So let's look first of all at the Grignard being a nucleophile. So let's take a ketone here. Acetone. And let's react it with a Grignard. Remember the definition of the Grignard we looked at earlier. Okay, it's where we have MgBr attached to a carbon atom. Okay. So we want to see how these two molecules react. Okay. Well, first of all, what was the property of a Grignard? Do you remember? What does it act as? It can act as a base. A base. Okay. So remember, whenever you see MgBr, what you can do, just go ahead and cross it out. Remember, like the alkyl lithium? Okay? And after you cross it out, to get rid of it, go ahead and put a lone pair on the carbon atom. Okay? So this thing will act as a base, or in this case, like you guys were saying, a nucleophile. Okay? Remember the definition, the difference between a base and a nucleophile. A base attacks an acidic hydrogen. A nucleophile attacks what? A carb. Okay, in case you forgot. So here, we're going to have this act as a nucleophile. So it's going to attack a carbon. Okay. Well, let's come over here and investigate acetone. Okay. The carbonyl has a strong dipole moment here. Why is that? Because oxygen is what? More electronegative than carbon. So remember, when you have a dipole moment, that you can draw partial charges. So the carbon is delta plus. So what would you say that carbon is? Starts with an E. Electrophilic. Okay? Electrophilic. And that's what attacks there? The nucleophile. Nucleophiles attacks electrophiles. Okay. So let's go ahead and look at the attack. Here's the mechanism here. That should be self-explanatory. So that carbon comes in and attacks the delta plus. And here's something new for us. The pi electrons go up to that oxygen. Okay? That oxygen, remember, is electronegative. So it's pulling. And here, it's able to now pull the pi electrons up after that attack has occurred. So everything is flowing toward that delta minus on the oxygen. So let's write the result of this mess. there's the result of this mess. Okay? Where now this ethyl has added on to that carbon that used to be a carbonyl. Okay? And now let's finish this mess. By adding H+. Where do you think the H+ will add to? The oxygen. To make what? An alcohol. So we get that. Okay. Remember that H+ can also come from H3O+. Okay? So in other words, H3O+ acts as H+. Okay? So sometimes books will interchange H+ and H3O+. They just do the same thing. Okay? So any questions on that? Okay? Let's go ahead and summarize it, shrink wrap it here. So this is the mechanism that you need to know. Let's shrink wrap it to something like this. Okay, so what it was a two-step reaction. Okay, so here we are summarizing it. Okay, so this would be an example that might be on your reaction page on the exam. And all I'd be looking for is the product. That you could draw something like that. Okay, any questions on that? Well, let me give you one, see if you can do it. See if you can draw the product for that reaction. answers here. Okay, so what do? Look at this one. The double bond O converts to an OH. And this thing here, at this carbon, adds on there. Like that. How many of you got that right? Okay, good. Okay. So start off with the easy nucleophilic reaction. Okay, the ones that we'll do on Friday are going to be a little bit more involved. Okay, so don't get too confident that you mastered that. Okay. All right, let me turn this thing off and then we'll talk about the exam.